Welcome back to our crystallography mini-series. Today, we're diving into two fascinating concepts that sound complicated but are actually pretty straightforward: polymorphism and isomorphism. Ever wondered how the exact same ingredient can create two completely different things? Or how different ingredients can create something that looks almost identical? That's what we're talking about today. Let's start with polymorphism. The prefix poly means many, and morph means form. So, polymorphism literally means many forms. This happens when a mineral with a specific chemical composition can crystallize into different structures, usually because of changes in pressure and temperature. The most famous example of this is carbon. Under immense pressure, deep within the Earth, carbon atoms arrange themselves into a strong, interlocking tetrahedral framework. The result? Diamond, the hardest natural substance we know. But at the surface, under much lower pressure, those same carbon atoms arrange themselves into flat sheets that slide easily over one another. This creates graphite, which is so soft you can write with it. Same element, carbon. Radically different crystal structures and properties. That's polymorphism. It's like having the same Lego bricks but building either a fortress or a car. The final product is completely different depending on how you put the pieces together. Now, let's flip that idea on its head and talk about isomorphism. Iso means same, and morph means form. So, same form. Isomorphism is when different minerals have the same fundamental crystal structure, but different chemical compositions. This happens because different atoms or ions of similar size and charge can substitute for each other within the crystal lattice. Think of it like a recipe where you can swap out one ingredient for a similar one without changing the final dish too much. A fantastic example is the olivine group. The basic structure of olivine can accommodate either magnesium or iron ions. If it's rich in magnesium, we call it forsterite. If it's rich in iron, we call it phyolite. Most olivine you find is somewhere in between, a mixture of the two. This is called a solid solution series. The overall structure remains the same, but the specific chemical makeup varies. So why do these concepts matter? Because polymorphism and isomorphism are like geological recorders. By studying which polymorph of a mineral is present, like diamond versus graphite, geologists can understand the intense pressure and temperature conditions that a rock has experienced. Similarly, the specific chemical composition of an isomorphic mineral series, like the amount of iron versus magnesium in olivine, tells us about the chemistry of the magma from which it crystallized. The crystal structure holds the memory of its